Hi, welcome to another episode of Unqork's No Code, Gary Hoberman, and this is going to be a really fun show because I've got one of my really good friends, Max Gelfer, with us here today, America's CIO for Chubb, leader who I met back in Goldman Sachs, his prior employer before that. But this is going to be fun. This is going to be all about just best practices in technology, what we've seen, what we've learned, and where the future is going. And again, each of my guests has been amazing driving where the future is going, not just following, but leading, which is what it's about. And so, Max, if you can do the intro for yourself to the audience, tell us about your background.
Totally. And Gary, thank you for inviting. It's sounds like fun. I love to have coffee with friends, even when I'm not in the office. So here you go. It's I had a really fun journey in technology. I've been working mostly for banks before. I have more than 25 years working in banks, 20 years in Goldman, and now at in Chubb in insurance. And I have to say, it's insurance is a lot of fun. It was a lot of fun in banking. It's a lot of fun in insurance. And the kind of looking back, the progression of technology, the progression how technology changes over years, and how we're using it, been fascinating, right? How do we enable ourselves, right? How we're trying to enable our clients, our users. How do we get the best for us, for developers? How do we get the best tools? How do we get the best environment? How do we make it easy for ourselves? So that's going to be an interesting conversation today.
Awesome. And Max, like with that, we're both engineers. So if I'm assuming, like, if I was working for you and I was in your team and you asked me to build something, as an engineer, the first thing I'm going to do is I'm going to say, has anyone done this before me? Like before I do it. And I guess the most basic example would be even things like logging, which we all do. Like you want to log, you have to go back to log, show the regulator your logs. It's for debugging. It's for when a customer calls up. It's so simple. And even logging, where you would basically say, let me find the library out there. There's got to be a good library for logging instead of doing a printf, or it's any print or whatever language, or system.out, whichever language you choose. And like there's libraries for logging, we all know. But of course, like if you embed that library, and I said, oh, I'm using this library, if I ever want to replace that library, you would say, like, don't hard code that library, let's build an abstraction. Like, so let's create our own layer within Chubb and say, let's system that out, and we have our own library, which behind the scenes might call, let's just say, even log4j or something like that, which we've all known well in the recent few weeks. And so it would call that, and like that abstraction is how, like, that's how I grew up. That was the idea back from every technology, including Clipper 87 back in the day, all the way through DBase and through Visual Basic, and then of course Java was where we built all our tier one systems. Is that how you think? Just, I'm curious your mindset as well in that.
No, absolutely. And the interesting thing, Gary, is for me, for the past 25 years, you always kind of think in algorithm. You think about what are you trying to achieve. And to me, I always kind of assume that we can build it well. And I also assume that we can reuse. But then you realize it doesn't happen in all cases, right? And it's kind of what I want to invest the time of myself and my team is building the best algos, building the best way to and algos not it's not just for calculation, it's not just for machine learning. It's literally like whatever we implement, right? How can we do it in the most elegant and the best way? And it also means that, and every time I look at a project, it also means that we don't spend enormous amount of time on something like login screens, right? I'm assuming that we build it, and if not, then how can we implement the layer where whether it's login, whether it's talking to databases, whether it is the common function, common function how to run clearance and insurance, or common functions how to enrich data is done for the developers. They work in the code, they work on what they need to develop instead of trying to implement everything else. And as you know, unfortunately, it's not the case every time. But yeah, I very much think of this as what are my building blocks? Where can I use it? And concentrate on what my team is building right now rather than generic functionalities.
It's you hit on. So I remember the days we would open a socket to a database and directly talk to it in its system protocol. I mean, I was a certified Sybase DBA back in '90s. Like it was. I don't know why I did it. I think I did it to understand indexes, but like God, what was I thinking? But it did give me insight. And you would open sockets, and then as you mentioned, like ODBC comes out. Open database connectivity, JDBC comes out, and there's all these, and then you want to, oh, you shouldn't talk directly to the data model. There's a data model in between, Hibernate, or an object model in Java. And like all of this is abstraction that we talk about. And those building blocks you mentioned in that aspect are what we've been using. So when we talk about codeless architecture, like the first thing we say to engineers is this isn't new. This is the path we've all been on. It's a path we've been on. Like if I think about Citigroup, Max, and I was building trading systems, and you think about mutual funds from Smith Barney and Solomon and Citi, and if you simply were able to consolidate those libraries, as you said, but maybe not the calculations, the algos, but most of the functionality in a single language, then when it comes time to something being end of life, there is no more end of life. It's done once. Instead of, as I'm sure you're familiar with, and even in banking side, end of life was a common project type. It was like, what are we working on this year? Well, we've got these 3 end of lives coming. Angular is coming as an end of life, which is nothing but an abstraction of the UI. So it's interesting. How do you think through like that aspect? How do you make sure what your team is creating follows those guidelines and enforce it?
Yeah, no, listen, you really hit on the challenges which we all have, right? I mean, so just to go back to what you started your question with is like when I look around, right? Like think about the open source. Think about all of the various whether it's Log4j, whether it is like you said Angular. All of these are ways to create common abstraction and use it in our code. And in some cases done very elegantly, in some cases it's not done elegantly. So the idea of reusing, the idea of creating these blocks of reusable code is absolutely not new. And like literally, I like you can write function in assembly. My first language was assembly, right?
Was
So
it?
like
Was
it's
it?
not.
I,
It was
when I
actual assembly.
So my first assembler code, Max, I got to say, I was not good in assembler, and I was using my first laptop was a Toshiba that I actually couldn't afford. So I purchased it from a pawn shop within Queens because it was like the only thing I could actually, as a college kid, afford. And I remember my first program I wrote with assembler, I pushed something to an interrupt on the motherboard, which created an infinite loop for like 3 days. It was like, and it was like,
100%.
so that's what you don't want to do, of course. That's the lowest level, which you don't get to.
Yeah, but again, the idea of reuse comes up, and the idea of reuse goes throughout our car. Like if you think about again, I mean, what's happening across all the development shops, right? Like everybody's adopting all the different patterns. Now, back to your question, and that is the frustrating point: is the second you put something into production, it becomes legacy, right? And like, don't kid yourself in whatever's new is going to be old again, right? And so every time when you put something in production, the point is, how will I keep it live? How will I keep it? And that's something explaining it to non-technologists, non-engineers, to say you can't. It's not just you drop code in production and it lives forever, right? You need to feed it, you need to water it, you need to upgrade it, right? And I don't have a simple algorithm how to do it. Honestly, in the environment where we all run, think of this as Java or C or whatever, C++, whatever you run in your shops. The only kind of invention is build it in well-organized services and then replace services or look at services at least once every 2 years and actually force yourself to modify it and adapt it to new environment or new versions of different software. But yeah, that's a challenge which is around, and in insurance industry it is around, in banking industry it's around, right? Any company who's been in existence for more than 5 years, more than 10 years, more than 20 years, have the problem of whatever we built well 20 years ago, today is legacy. And today is deep legacy.
Yeah, and it's funny because I remember like my first job ever, and it was on Wall Street in foreign exchange. I was given a task which I thought was so boring. It was Okay, there's a senior programmer analyst, if you remember those titles in those days, and he had basically created this exchange system, and there was some intermittent bugs. And for those who aren't supporting systems, the word intermittent is a fun word because sometimes it's user error or sometimes it's system error. And so I was given the job to debug it. I wasn't creating, I was just fixing. And I was like, God, this is going to be boring. What I learned in going through someone else's code was best practice. And what I saw was on every function, he started off with something called on error resume next, which basically meant, as you know, Max, it means if you find an error, just skip it and go on. If for those in Java world, it's like a try catch with nothing in the catch. And basically and so once you removed that, all of a sudden everything started blowing up. Every single thing you started to see what was really, it wasn't intermittent, there were bugs. And this is, now what's interesting is I've seen this throughout my career in Wall Street. And for 20 years, that same methodology. And when something's in production, I would spend, 2 hours every Friday morning going through outages for the previous week. And then, with 10,000 engineers in my team, and we do a small group, of course, not 10,000 in that one call. That would be pretty bad. But and then basically the next 2 hours would be spent talking about what's coming up on the weekend with all the release backup plans to make sure there's no issues. And if there's an issue, back it out. And there was no actual really functioning backup plan. It was always move forward, always try to figure it out because you got to get it in. But the second it was in, you would be talking about outages on the same app next week. And it was this continuous process, which that's when we created Unqork, was how do we break the cycle? How do we actually stop that? And that's what, and it's not what you want your time spent on. I mean, you're an engineer, your team's engineers.
Yeah, listen, Gary, that's you bring in whole number of different points, right? It's at the end of the day, right? It's the quality of the code, it's the quality of comments, it's the quality of task coverage, it's the quality of deployment, and then it's the quality of being able to back it up, like you said. And that's like I don't sleep a lot, so I sleep. By the time I get to bed, I sleep. I fall asleep quite quickly. But if I would not, what would keep me awake at night would be the quality of the code, right? And that's what worries me, right? Do we do enough? I mean, do we do enough for the new code? And how do we remediate the problems in the old code, right? And I've done it many times in Goldman. I've done it many times in Chubb now, where you actually, like, when you see a problem or you see a challenge, you do a code review and you go into code and you start asking questions. And some code is fantastically well documented and organized and covered with tests, and some is not. And then the question becomes, how do I know, like you said, what do these people, what do all of the engineers, whether it's dozens, whether it's hundreds, whether it's thousands, how do I know that the quality of the code they write is the quality of the code we expect, right? How do I know that they follow the same processes? And listen, obviously we have code scanners, and obviously we have practices, and obviously, but at the end of the day, it is an individual who's writing the actual code, and this individual has a lot of power. How do I at the end of the day say that the application is functioning normally if I don't know, ultimately that every piece of the code is written well? So it's a fascinating question, a fascinating problem, and that part of it is also goes back to all of the engineers, right? I mean, we all empowered to make such a huge impact on what runs in production.
It's and it is, I like the word empowered. Like it's you're communicating with a machine and it's powerful. It's you're telling it what to do, you're in control of that. So the concept that we've launched codeless architecture, and Max was along this entire journey with us, brainstorming ideas and what this means and how it goes. Like that's really what it's about. To us, is just we're specifically saying, like, there's not just one tool that will ever do everything. Like there's no way. If anyone's ever selling you a solution and saying, hey, top to bottom, we've got everything you need built in to do everything you can. And by the way, if anyone's selling you a solution that's a single stack, single cloud, you're locked. That's where you don't want to be, right? That's where, so like the whole concept for us is abstraction. It's bringing the best of breed. That's the definition. Codeless architecture for us is just snap in the best of breed technologies, because your world, within insurance. So like you, I left banking and capital markets into insurance, and I did that in 2012. And it's really amazing. Like I will never forget that entry. And I kept hearing it's complex, systems are complex, and I kept thinking to myself, probably as you did, like trading systems is complex. Like you don't sleep, and there's you make an issue and you take down the trading floor. Like that's complex. That's so so like to me, solving that complexity, it wasn't. It was just business rules. It was just a lot of rules coded. And so, like in our definition with codeless architecture, we're absolutely saying, as you started, the algos, the areas where your engineers will excel and what they excited to do. They're not excited to move a button around the screen. They're not excited to respond to Angular's end of life issues, or maybe a database end of life issue that's coming, or maybe a vulnerability found. They're excited to create. And that's what we are. That's what you and I are, as engineers that create. But that's the view. I mean, tell me what you think. Is that
No,
on?
listen, I love what you're saying because I've seen many times, and listen, we had these discussions in the past, you and I. Um, uh, the codeless architecture, low code architecture, whatever way you want to say it, does not. It's actually, I think, promotes the developer function. It does
Right.
not eliminate developer function, right? Every time when you see people or hear companies talking about how we're going to empower business users to write their own code, you've seen it many times, and I'm not going to spend time on this, but that's a challenge. But can I empower my developers? And I want to do it, right? My daughter's taking Java classes now, and we work together on this. We do peer programming together. It's so much fun. It's so exciting. You see the result. And so, can we empower ourselves to spend time on actually figuring out the best way to implement? And I'm going to say algos again, because anything is an algo. How do I organize the screen in the best possible way? How do I make sure that this is how do I ensure that it's actually intuitive for whoever's using it, and the answers popping up or the suggestions popping up all throughout, right? How do I in insurance? You're right. It's the product themselves, and I'm sure a lot of people from banking listen, but the insurance products are more complex than banking products. It doesn't have the same trading component. So business rules are so important, right? So how do I spend my time figuring out the best way to organize and code business rules, but not how to organize the code and put all of the comments and in the code itself? How do I spend my time figuring out the best way to implement and run it on a machine, like you said? That's exciting. That's because it's something where it always fascinated me from the very beginning. You put instruction in the machine and it does what you want. Here I can be so much empowered because if I have a clear view, clear vision of what I'm doing, I can do it very quickly. I can see the results. I like it. I don't. I change it. I move forward. It kind of makes it really exciting to create the very rapid cycle of deploying new ideas in and optimizing new ideas. So along the way as well.
Yeah, I mean, and for those unfamiliar with insurance, because we are now both into that and we understand it. Like, if you step back and say you're applying for life insurance or auto insurance or home insurance, or you're building a business and you do workers' comp or general life, it looks very similar to open a bank account or opening a trading account, an institutional trading account. And it's this pattern of, collect information, integrate that to your systems, validate it, risk assess, whether it's an underwriting, it's always underwriting, and basically accept it into your books or reject it. It's a pattern which you could apply to everything. We see it when we're saying you want to get married, and we marriage license system, it's Unqork,
Sure.
and that's the same thing. So it's interesting though, but with insurance, the one thing that's different than banking, and I'm sure this is what you see, is there's two aspects. One, businesses want to be able to innovate those rules. And so I remember finding one product in Japan, which you could insure the whole body for medical on the hospital insurance, and you could then deselect components of your body, like your thumb, your right thumb. And like the rules around this, you can imagine to structure this product. And then the other aspect, even in the United States, where people might see commercials for Chubb and basically products and what we're offering. And I'm a big customer, of course, of Chubb myself. People don't understand that it's not national regulated, it's state regulated. And there's 15,000 state regulators telling the insurance companies what to do, what to call it. So there's no, on the business side, there's no uniform approach. There's no JDBC library to connect to a database, in essence. There's no abstraction. And that one simple product that you might purchase yourself within New York or California might look like 50 different products to you, the CIO of Chubb. And basically you have to support with all the different variations and roles. And I think that's why when we created Unqork, we started in insurance. I didn't start in banking because banking's easy. It doesn't have that same complexity comparatively. And said, if we could get insurance working, we could do banking after, which is what we did. Which is, is that what you're seeing as well from a business point of view? Similar roles?
Yeah, absolutely. Listen, the insurance is just such an exciting field for the engineer because there are so many opportunities, right? And there are a lot of opportunities for the business as well, right? I mean, in insurance, what I found fascinating, the applications is a product because you need to be able to define the product fully, and you need to be able to price it, you need to offer it to client, and you need to bind it, right? And it's kind of the application and product are almost the same. And our ability to innovate, our ability to change is based on how easy we can modify the code, how easy we can change it, how easy we can test it, right? Because we need to make sure that whatever worked before, and you talk about regulators, you talk about the people who buy insurance, you need to make sure that you actually don't change the parameters of what you offered before. But the opportunity of this rapid change and innovation, enormous. And at the same time, it's kind of, you look at this and you've seen what happened in other industries, you know that it's going to come. And, whether you can argue whether it's the next 3 years, 5 years, 7 years, or 10 years, but you know that innovation will come into insurance. So how do you do it without the pains we all incurred in banking? How do we do it with lessons learned? How do we optimize this path is what we're talking about here. How do I organize the teams which are working for me to be to be effective, to be efficient, to make sure that we test it, to make sure that we deploy it well, and without spending thousands and thousands of hours on things which can be reused.
Yeah, Max, this is one of my favorite conversations. It's the business doesn't understand the technical side of what we just went through. Like, to them, this is foreign, and but the technical, like, I've lived and you live through this every single day, and it's what it is, and it is a challenge, and it absolutely is, the future we're setting in motion, which finally should address all this legacy, all this past that we talk about. And I love the comment around just everything we create today is legacy tomorrow. It is absolutely the case. It's, we are fooling ourselves if it's not. And this is, Max, this was such a pleasure to be talking to you again. Always fun. I love that I could bring some ideas with you. So I do call Max and say, what do you think of this? And what would you do? Max challenged us also with something which we still haven't done yet, the naming of the language, which we're going to have to get back to one day.
Absolutely.
But we're going to need good marketing from that, and we'll come back. But it's just been amazing, Max, having you on. I appreciate you joining us here on another episode, Coffee and No Code. And I look forward to seeing you soon, Max. Thanks again for joining us.
Thank you for inviting me. Thank you very much.
Thanks,
Bye.
Bye-bye.